Welcome to the Additive Report Advisor, a webcast series that supplies fabrication and machine shops with the insights they need on additive manufacturing. Our guest today is Mark Abshire, a man with deep hands-on experience in both additive and subtractive processes. Now, this is the first in our series of discussions meant to help machine shops connect the dots when it comes to additive manufacturing. I'm Todd Grimm, your host, and I'm going to use my experience of 30 years in the additive manufacturing industry to make sure these conversations stay real, stay informational, and never stray into infomercials. Now, these conversations are all focused very squarely on small and mid-sized businesses who are wrestling with the 3D printing technology or the 3D printing questions, starting with the very basic question of should we or shouldn't we, and then digging deeper from there to understand how, when, why, and what you can achieve. Now, all this is based on a premise. We know that additive manufacturing can be overwhelming and confusing, but a lot of the information that flows to us is from the successes of large corporations. Now, those large corporations aren't like you and your small to mid-sized job shop. So what we're going to do is have conversations that get real and cut through the hype in order to provide you with real insights and practical information to plan your additive manufacturing approach. Bringing you this information is made possible by the support of sponsors, and I'm very pleased that in this inaugural episode of the Additive Report Advisor, we have two sponsors, Trumpf and Thermoid Corporation. Trumpf is an additive manufacturing pioneer with a 20-year history. Its approach is to supply industrial solutions to the AM world to bring 3D metal printing into series production. It is one of the few companies to offer two distinct technology platforms for metal additive manufacturing. It offers laser metal deposition, or LMD for short, and laser metal fusion, or LMF. In the category of LMD, their systems are hybrids, meaning that on one platform, you can do both additive work along with cutting and welding. Our second sponsor, Thermoid Corporation, was established back in 1969. It's US-based, multinational, and diversified as a machinery manufacturer, and it supplies its products and services through offices in 11 countries. It's also the first and oldest to supply flexible 3 and 5 axis high-speed machining centers, specifically CNC routers. It's also developed into a technological leader in this field of large-scale additive manufacturing of thermoplastic composites. It offers systems, LSAM systems, which stands for large-scale additive manufacturing, that range from 10-foot by 10-foot build area up to 10-foot by 40-foot. Now, they're using reinforced thermoplastic composites to make everything from bucks to patterns to molds to fixtures to tools to support industries that range from aerospace to automotive and boating, and supporting processes or applications in the foundry space such as metal casting, and also in the plastic processing space such as vacuum forming. Now, with all of that said, it's time to invite my guest, Mr. Mark Abshire. Mark, welcome to the Additive Report.
I do.
Before we dive in, Mark, I want to offer a little bit of background and bio on you so people understand where you're coming from, what experience you have, if you're pulling our leg and don't know what you're talking about. So can I go ahead and give you a bio?
Sure.
All right. So Mark has been a pioneer in the 3D printing industry for over 30 years, but he started his career or his professional career as a machinist and toolmaker in the early 1970s. He followed in the tradition of his father and his grandfather. He's run lathes, mills, horizontal boring mills, EDMs, jig borers, and much, much more. Now, after starting with the new technology of stereolithography in 1988, he's continued to monitor and work with new and developing technologies in the additive manufacturing space, including FDM, or fused deposition modeling, laser sintering, polyjet, and many, many more. Now, Mark's spent the last 20 years as an application engineer for additive manufacturing, which means that he helps develop applications for companies and helps train them on the use of additive manufacturing. Yet Mark continues his tradition of machining by teaching mill and lathe classes at a local makerspace in St. Louis, Missouri. Finally, I'd like to mention that Mark, congratulations, has moved into semi-retirement. So there's the possibility that he may be taking on some consulting projects maybe the ones that he chooses to. And if you're interested in reaching out to Mark, you can get a hold of him at abshirem@gmail.com. So Mark, with all that preamble, I want to get started with the questions. And I want to start with one that really caught me off guard. When we were talking about what this conversation would look like, where we're going to go, you mentioned that you believe job shops have an advantage when moving into additive manufacturing over all others. Now, I've never heard anyone say that. Can you elaborate? Can you tell our audience?
I base it on my personal experience, and here's the reason why. The most important thing, or one of the most important things I would say in additive manufacturing, is your setup of your machine, the setup of the part in particular. It determines your part strength. It determines your part finish. It also determines your aesthetics overall for a model. Now then, machinists understand about part setup. They understand how they're going to have different operations and position in order fashion, where it goes to the mill first and then the lathe, or vice versa. It goes to the lathe and then the mill.
Wait a minute. I don't trust the word you're saying. Verse versa? I think
verse versa. You know what that is?
Vice versa.
That's just the opposite of vice versa.
Yeah, it is.
So it's verse versa.
Okay, you're going to turn everything on its head throughout this conversation.
That's right. Great. That's right. I'm going to keep everything square-indicular, okay? Those are machinist terms. So anyway, they understand what the operations a part has to go through, and that's critical for your additive manufacturing. So they get that advantage where somebody just learning, especially when you're looking at layer lines, how things are stacked up. They don't always understand how things might be under tensile or under pressure, strengths and pulls on that, and their parts will fail on them, where a machinist has a better understanding.
Gotcha. So you're talking about it's an understanding that the whole thing is a process, and they have the fundamental knowledge to apply past experience to this single thing called additive manufacturing.
They understand process. They understand doing the detail work last, not first, things like that.
That's an interesting take. Like I said, I've never heard anyone else lead with that. Now, is there any danger or traps of that? And what I mean by this is I find that a lot of times people will take past experiences and knowledge and apply them without any additional thought or consideration to additive. And that can be a trap in that additive is so similar, but yet different. And it's the differences that can get you. Have you ever seen anybody step into the trap of, I know what I'm doing, I'm just going to transfer it right down?
There are traps. And here's a really good example of a trap. When we think of 3D printing, we think in a machinist world, we think about everything being square and perpendicular, and we think about how we design this particular part. This is an actual part for a end-of-arm robotic tooling. So I had a customer that was building his parts just like he would traditionally machine them, like this. And I said, look, we can build on a 45-degree angle. It's still the same opening, all the same tubes, air fittings, everything will fit down in there, but you save a lot of build time and a lot of support time cleaning this out or cleaning this off just by taking that support and breaking it off. So these are the traps. You've got to rethink how you design things for 3D printing.
Makes sense. Makes sense. I want to lead with one other advantage that you see for machine shops versus any other business going into additive manufacturing. And that is, as you mentioned to me, that they've got the understanding that you have multiple tools at your disposal. And it's a matter of picking the right tool, the right process, the right machine for an individual or a given operation. So can you elaborate a little more on that? And why?
Yes, this is one of the biggest problems. And even if you're not a machine shop, if you're just looking at 3D printers, the problem is that there's literally thousands of 3D printers out there. There used to be a time when there was only 3 or 4. Well, patents have expired. More people have gotten into it. It's gotten simpler, easier. Just like everything else progresses, there's pioneers, there's settlers. We're in the stage right now where we've got a lot of settlers because things are smoothing out. with 3D printing. It's no longer run on MS-DOS, like when you started. I'll say the old days when you started.
Like when you started. That was back in 1988.
Yeah. So things have gotten a lot easier, a lot smoother with it. Materials have certainly gotten better. So therefore now you've got this wide array to choose from. But if you're a shop and you're looking for that perfect 3D printer, give up now. And I say that because if you're out there looking for that perfect mill, that perfect lathe, you didn't find it. There's always limitations out there. You just have to pick what's the best for your situation for the type of builds that you do. And also think about this, 3D printers, they have different technologies. Well, if you're a machine shop and you only can buy one machine, do you buy a mill or do you buy a lathe?
Depends on the work that you're doing.
It depends on the work, exactly. And it's the same way with 3D printers. It depends on what you're going to do with it. If you're going to just make marketing samples, there's a lot of choices out there. If you're going to make tooling and fixtures and things like that, there's a few choices there to make too. If you're going to be doing metal, well, now you're going to have to talk about which metals you're going to do for the metal machines out there that are 3D printing. Not all of them print titanium. Maybe you never work with titanium and you don't need that option. So you've got large choices to make just like you would pick any other machine tool.
All right. So what I'm hearing you say, or I'm going to interpret something here. So A, don't assume the one technology you bought is going to be able to do all of your additive work.
Correct.
To expand that out, and I think this is a real key point, tell me if you agree, is that it's also, once you have additive, opening your eyes and saying, okay, is additive the best, or should I stick with my mill, my lathe, my EDM, and decide operation by operation, part by part, what is the fundamental process you should use? Is that a true statement?
That's true. In fact, what most people do is the 80-20 rule. Pick what about 80% of your workload. The other 20% you can always subcontract out, but pick what's about 80% of your workload. And even when you're looking at the machine size you're going to get, look at about 80% of what your machine size. You don't need something so large that in 3D printing, the advantage is you can build it in pieces and bond it together.
Okay. Well, you've already alluded to this, but I want to have you really go into some detail. So I want to go for my first additive manufacturing machine. We've been using the terms interchangeably, additive manufacturing and 3D printing, which many people do. So the first additive manufacturing machine or a reset, I've already made a bad decision. So someone wants to get this new piece of equipment. We'll just say it's the first one. What is your recommendation? Yeah, and you've already alluded to it, but what is your recommendation for what they should do to pick that one technology?
Well, they've got to look at what they're going to use it for and their workload. For example, if you're going to use yours to address tooling, for example, a lot of CNC time where you could be making parts is sometimes tied up with tooling. If you can make a fixture for your CMM, if you can make a fixture as a holding fixture, remember you can put inserts, you can put nuts and bolts in these parts and then continue building. You have them embedded in there for your fixture. So doing things like that will ease up having to buy maybe another CNC machine, because when your workload increases, you decide, I need to get another CNC machine, another metal mill, another metal lathe. Maybe not. Maybe you offset some of that with some tooling work that can be done in plastics. Now, if you're doing tooling in plastics, that's a big gain in ergonomics, especially assembly fixtures where people are having to pick up fixtures and move them and stuff. And a plastic assembly fixture is a wonderful thing.
Okay. So how finally should they narrow this focus on, get my mic, focus on an application? So you said tooling. If I'm going for my first machine and I want to focus on application first to decide what I need, should I look at the whole bucket of tooling, or should I narrow it down to specific types of tooling? You mentioned CMM fixtures, you gotta have welding fixtures.
Okay. So decide if your shop uses a lot of shop aids. Shop aids are typically assembly fixtures, things to hold, jigs to hold something, just a drilling fixture or whatever. Once you determine what kind of tool you want, now you got to determine what kind of strength you want. This is my opinion now. I determine what strength do I need. I don't necessarily need metal, but maybe I need something stronger than PLA, which is a plant-based material. Maybe I need a carbon fiber, for example, something very strong. Well, once you determine what material you need, maybe I need ceramic in there, so because it'll take the heat, thermal properties of it. But once you determine what material, that will help guide you into what technology. Too many people pick the technology first and then try to discover what materials run on it. If you know what materials you need, it's much easier to guide into the technology from that point.
All right. So you said too many people make that mistake. So yeah. I'm going to reinterpret that to, it's rather common for you to walk in a shop and see a machine that isn't being used or is tarped because...
Well, what they do is they'll buy some hobbyist machine and it won't produce the results they want because like who would buy a milling machine that fits on a bench top when you really need a CNC mill? Well, they know the difference, and it's the same out there in the industry. There's a lot of hobbyist machines, and nothing wrong with them. They're great. They're good to learn on. They're good for students. They're good, but in a professional setting, nobody has a typewriter anymore in their office.
Now, so with that, I'm hearing you. I'm going to reinterpret something else. And again, you correct me if I'm wrong, if I'm getting your words wrong. So having you said hobbyist machine. So we're, low cost desktop machine, couple $1,000. Yeah. If someone has had a less than desirable experience with that, are you recommending that they stop and say, that's not everything that can be had off of, let's say, an industrial grade machine? So you've got exposure, but don't assume that that is telling you the whole story. Is that correct?
Well, that's correct. And what I'm saying is, you know that there are some limitations with that low-cost machine. There's limitations on the materials you can do. There's limitations on the, they are getting better. There's limitations on materials you can do. There's limitations on the accuracy. There's limitations on the quality of the part as far as bond strength when they're layered together. So just know your expectation ahead of time that, okay, we're getting this low-cost machine just to get our feet wet to find out what direction we need to go.
Okay. All right, so what direction we need to go? Any high-level recommendations when it comes to, should my first machine be plastic or metal?
Yes.
What's the recommendation?
Your first machine should be plastic or metal. The only answer is yes, because it's impossible to say. Some fixtures must be made out of metal, therefore metal is the way to go. I will caution you on the metal, though. One thing that that no one particularly tells you about the metal machines is that when you look at a wrought material that you're using in the machine shop, you look at castings that you may be machining in the machine shop, your powdered laser metal machines have no grain structure metallurgically. Grain structure is a big deal. So if you're looking for something for high strength, not every part needs that. That's okay. But if you need that grain structure metallurgically, you're not going to necessarily get it with the powdered machines.
All right. Now, I was going after that question from the angle of which one is easier to adopt and implement.
Oh, of course, the plastic is easier to implement. It's very simple out there. Whether it be stereolithography, it's a little more complex. FDM is probably the simplest to understand, the least amount of maintenance on it. Depending on what level of machine you get, professional or hobbyist, is how much tweaking you do on it. Getting a professional fuse deposition FDM machine, you can just walk away from the machine and let it run. Getting a hobbyist one, you're going to find more time tweaking it. So how much operator time do you want to spend on that machine?
Now, job shops in particular, what would your usual recommendation be, or let's say on average, for someone that is starting flat-footed? this is the first venture into additive. Well, let me turn the question around. Do you think it's wise that someone dives into metal additive manufacturing as the first step and no other exposure to additive manufacturing?
I find that very risky, extremely risky, because you're adding a lot of components at one time, a lot of variables in your metal. Not only are you starting out with additive, but you've got a lot of safety regulations when you start working with powdered metal and things like that. I know people that do it, that have, everyone that I know that's done powder has started with some other technology first, either FDM or stereolithography or selective laser sintering. They've started with some other technology first and moved into it. If I was going to move into powdered metal, I think I would start first with selective laser sintering of plastics, because you're melting plastic to create a part. Therefore, melting metal is just the next logical step up.
Makes sense. Makes sense. Now, they go through that process. They've got a machine, or actually, you've already mentioned, pick the application first, and you've telegraphed this, but I'm going to ask you to elaborate. So for a job shop, machine shop, fabrication shop, what is the low-hanging fruit with regards to applications? What is your recommendation? Not knowing these individuals and their company needs, what application bucket should they start with?
Well, there's really two out there. In fact, I take all applications, and this is my personal opinion. I've not read this anywhere, but I'll divide all applications into three groups. You have a marketing applications, where you're just making things for customers to look at and to see before you invest tooling. You have the engineering application, where you want to check form, fit, and maybe some function on it. And then you also have the manufacturing, where you're going to use it as either the end item or to produce the end item. So when you look at those three buckets, marketing is just making parts that you're going to simulate and let your customer look at, hold it in his hand, get that tactile feel that this is the way it's going to feel in my hand, and you haven't invested in any tooling. For engineering studies, you've got materials out there that will that you can do FEA analysis on. You've got materials that you can do heat, thermal properties out there that you can do your testing. You can even do injection molding with it, but that's more into your production line. But for your engineering testing, you've got all kinds of strength and things like that. And you can machine it if you need closer tolerances. Now, you move in production, you can actually make end item parts. I've seen lab on a chip where parts were so tiny, they'd take a drop of blood and it would separate it for testing on there. And so those are actually end item uses. Injection molding, that gets you to an end item use. A casting pattern, when you just need 5 castings and you don't want to invest in a tool to make those, you can use additive manufacture to make castings with. So those are all production type applications. So there's a wide range of production. So back to your original question, you asked which one are you going to start with? Well, you have to decide if you're going to use this for engineering use, marketing use, or production use. Just take it down to those three and decide which one you want.
I'm surprised, Mark. I thought you would jump all over fixtures, gauges, manufacturing aids as
well. It depends on
most job shops.
It depends on your shop. If you're a plastic injection shop, you don't need to make a lot of fixtures for plastic injection shop. What you do need to do is make a lot of models for your customers to approve before you go cut your molds. So if a customer,
I'm going to cut you off, Mark. We're talking to machine shops.
Well, we're talking about machine shops. Yeah, we're talking about machine shops that make molds too, though.
Okay. So you make
nobody likes to recut molds over and over again. In fact, well, maybe I'm wrong. Maybe a machine shop likes to recut molds, so that's continued income for them. Yeah. But if you want to get more customers out there, you will make sure that you've got parts to say, okay, this is what you're going to get out of this mold. This is what you're going to get out of this mold. And then they have an idea to look at, let's make some changes. You saved a lot of effort. You save a lot of time to market.
Right. So I want you to clarify though. So in the additive manufacturing space, the things we read today, the whole conversation is about production, 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 implying that I am going to do my entire production run of finished goods that I sell to my customer with additive manufacturing. Do you want to offer any caveats or any color commentary to frame that? Again, for the job shop, should they go after that? What I'm asking, should they go after that hot and heavy because everyone's doing it and that's the winning application, or should they look at it a little bit differently?
You've got to look at it differently. We're not there yet. The material properties are not there yet. The materials themselves may not be there yet. Just because you can put together aluminum in a metal machine, here again, no grain structure to it can make a big difference in the function of your part. I don't want a landing gear on my airplane made with powdered metal. Sorry, I just particular about that.
I think you just made some enemies, Mark. You might want to watch your back. So,
well, no, I want to be on an airplane. I just don't necessarily want to do it out of powdered metal.
Well, no, I'm not talking about the aircraft manufacturers being after you. I'm talking about the suppliers of metal AM solutions.
Oh no, there's lots of parts that can be made, jet engine parts and things that can be made out of powdered metal that don't require that kind of load. Don't get me wrong. There's certain parts that you don't want, but there's certain parts that you can do at the same time. So not everything has to be. You made the statement that just go for it and let's do everything out of additive manufacturing. That's what I want you to guard against, not everything out of it.
Okay. All right. I'm going to go back to one of your early statements in this conversation. That's, after patents expired, hundreds or thousands of solutions out there. Mm-hmm. It is a very big landscape of process types, specific machines, manufacturers, a lot to choose from, which can be quite overwhelming. How does a job shop, and I'm assuming everyone has real jobs, meaning that they're going to be busy 8 hours a day, so no one's really got the time to turn this into their full-time job. But any recommendations on how a job shop can get the information they need to A, pick that right technology, and B, to implement it and take control over the process? Because
of course, there's really several ways to do it. One is if you're going to dedicate and do the research yourself, that's fine, but you're going to be swamped on the internet. So if you're going to do your own research, start looking at similar companies, look at competition and see what they have. For example, if you make wind turbines, go out there to somebody else that makes wind turbines and see what they're using. If you're doing automotive work, let's go take a look at what the other automotive people are doing, because there's case studies all over the place for every technology out there, and this will give you a good example. However, the better way might be, and I hate to give you a plug here for free, but to get a consultant, Todd, somebody that's been around for a I know you're wincing. Somebody that's been around for a long time that can help guide you down that path. And it doesn't have to be a long, drawn-out process. A lot of times for you and I that have been around a long time and seen a lot of applications, somebody says, okay, this is what we make. It might be, oh, I know other people that make something similar, and here's what they use.
Well, I appreciate the shameless plug. I wasn't looking for that. I'm not even sure I said I was a consultant in the introduction, but I'm going to do another shameless plug. You happen to have a logo on your shirt there that says AMUG.
Yes.
What's AMUG?
AMUG is an additive manufacturing user group. So just like if you have CAD or other user groups, this is a user group for people that own additive manufacturing machines. They have a conference once a year. It's actually going to be coming up in March in Chicago this year in 2021. I think it's March 14th. The conferences are users, and it's for users by users. The board of directors, all the people that put it together on the staff are actual users out there in the industry. Now, we do have a small show where we show the technologies, where companies come in and show their technologies, But the thrust of the whole conference, and it's like a 4-day, 5-day conference, the whole thrust of it is to educate, where people are doing presentations on here's what I've done with 3D printing, here's what you should be looking for in the next 3D printer, things like that. And I'll throw it back at you by saying Todd has been an advisor for the AMUG for many, many years. And I won't even say how many because I don't want people to think you're as old as I am.
But I am. So I appreciate that, Mark. So it's, bottom line, AMUG is it's a source for real world information coming from the mouths of those that have experienced it. So you're not relying on salespeople and others who have an agenda. Instead, you get information.
It's a great networking because you sit down with people and you say, I got this problem on my 3D printer. Here's how I solved it. That's the first thing you're going to hear is, oh, I've seen that. The worst thing a manufacturer tells you, and I've heard this so many times, I laugh, but they go, well, you're the only one that happens to. Well, that's not true. So once you get a group of people around, and AMUG is famous for every time you have a lunch, an event, you sit with different people, not with your own group. You pick a number, you go to that table, you're now learning to network with other companies, other people that have similar machines, and this gives you a chance to discuss, not with the manufacturer, but with other people that use the same technology.
I agree. So I'm going to just button this thing up. So key recommendation is for job shops, don't try to go it alone. Don't try to scrape information off the internet. And even once you've made your decision, surround yourself with other knowledgeable people that can help you solve problems or do new and creative things.
Exactly.
Agree? Okay. Now, with all your years, application engineering, you're interfacing with a lot of job shops and certainly other type of business entities. But in the job shop environment, is there any common fails or failure modes that you see that you want to advise people to avoid those traps? Now, where I'm going with this, Mark, I didn't frame the question right. In discussing what we wanted to chat about, you mentioned that a problem that you see is people hogging the machine and shutting down creativity, meaning that this corner of the shop, they took ownership of the additive manufacturing process. And
yes, I see what you're getting at. Yeah, that is one of the biggest problems out there is when a large corporation gets a 3D printer, they will create a corner to put it in. And nobody else in that corporation knows that there's a 3D printer there. So I've actually seen corporations go out and buy another one in another area when this one's underutilized, that they already exist. So keeping it a secret is the biggest problem out there for people, and not letting it be creative. It's very easy in a corporation to have your own entities, your own empires that they like to create out there. But if you can get a center of excellence or a center place for 3D printing where you have all the technologies together, then everybody knows what's available. If you're in a large corporation, and even if you're a job shop, let's say, and you've got a 3D printer out there, make a few giveaways out there. If you're from the north, they call them tchotchkes. If you're from the south, Louisiana, we call them lanyap. But anyway, make a few giveaways out there. The giveaways are what you're passing out to customers, you're passing out to other engineers to let them know that you have this capability. It's as simple as running a little keychain part with your company logo on it or something like that. And for me, here's the way I do it, just to let you know. I come in every Monday morning. I've got about 4 or 5 machines. I come in every Monday morning and I will start the machines and I will run a little giveaway on them. Something only takes 10, 15 minutes to run. And this does 2 things for me. It builds me a little bit of inventory, but it also lets me know that my machine is functioning properly on Monday morning when my work week begins. My machine is functioning properly. If I didn't get that little giveaway printed out properly, I got to call maintenance, get the machine worked on. There's nothing like waiting until you have a job on Thursday and then calling maintenance. You need to know that your machines are always running and ready to go during the week. So that's why I utilize that to fit both scenarios.
All right. Now, you went to the large corporation, so let's drive it back down to the smaller business entity, the job.
Okay.
So obviously, there's not going to be a remote department that you never see that takes ownership, because I'm assuming the shop is in the same, between the same four walls. But do you still see kind of a mine attitude where it becomes a machine dedicated to fill in the blank, making the marketing samples you're talking about, or making fixtures, and it stops the creativity even within a small shop?
Exactly. I've seen shops where they create fixtures for their machine shop, just shop aids, drill holding jigs, things like that. But then they don't think about making a fixture for their CMM quality control department. A CMM fixture is not much different, if anything, from a holding jig out there. So they limit themselves by not expanding and being creative enough. In fact, you've got to constantly expand and say, okay, what if we used it for this? If you've got a complex part that you're trying to machine and you've got a complex drawing, maybe you 3D print that first so you can hold it in your hand and look at it and say, gee, I got to set it up in this way to get all my parts functioning properly, all my features on this part. So that's one of the things is limiting the scope and not expanding out there.
Makes perfect sense.
And it's just like any other mill or lathe out there. You run them to the limit. You find out, you got to get your rotary tables, all your little attachments out there. You're always taking on new jobs that you've never done before. Same way with 3D printing, new things you've never done before.
So build on experience, but keep pushing outwards.
Right.
Do more challenging, do more interesting, and even do different applications. Okay. Well, twofold. Actually, no. I want to. You mentioned something, and I'm going to ask you. So, in metal additive manufacturing, so we are where we are. What do you think the future of metal additive manufacturing is, or what exciting technologies are coming about that could create new opportunities or push the technology farther into adoption?
It is growing so fast. We've got new materials. We've got new technologies. I know there's several out there that are being developed now to a little bit different spin on what we have existing out there. But I think one of the best things to come down the pike, and I kind of regret that I'm retired, because I think this is going to be a whole new generation of design work out there. And I've got a little video here. I want to share my screen and show this little video I've got of a part that actually works for the design world. Let me share my screen real quick. Okay, here on my screen, you should be seeing a design here. This is a design program, and you're seeing two entities here. One is a fixed location here. The one down the lower right-hand corner, that's going to be a location that is not constrained. It's out in space a little bit, but I want you to watch this video. This is actually generating, it's called a generative design. And when you watch this video, it's actually growing based on how that lower bushing there has to move around in space. So it's going to grow like a tree root. It's organic, just like a tree root will grow to brace itself in the wind. So to me, this is an exciting design feature. You'll end up with a part, something like this, that you couldn't really machine out there in the real world, but yet this is designed to be a lighter weight, and it's also designed to 3D print out there, and you still have machine stock, for making your locations and your hole sizes.
How's that affect the job shop? So, your experience, are most job shops doing original design for their customers, or taking the designs from their customers, or is it a 50-50? And
Most- yeah.
just setting things up here. So your experience, job shops designing the stuff from ground up, or are they taking designs from their customers?
They do both. Some job shops offer a service to do the design work. Some job shops take in work that's already been designed. If you're building, I had a job shop once that was doing a lot of work they were taking in. And I said, why are you cutting a draft, spending all that time to cut a draft angle on that part? Well, that's what the part called out for. Well, it was obviously designed to be a production part later on down the line, but the job shop was cutting the draft angle on the finished part. That's a lot of time wasted in there. So you need to be smart with what you're doing. Now, if the customer required that because they want to look like it was out of a sand casting or whatever, that's great. But it's not necessarily the most efficient way to do a job. As we look to this part, we're going to see there's no draft angles, things like that. So you look at a whole new way of thinking of design in the world out there.
All right. So the other side of the equation, Mark, is if this becomes the norm, this kind of design, what are your thoughts on job shops being prepared, meaning having additive and being capable in additive to be able to accept all these funky designs that may or may not be able to be machined? Do you think this is going to force them into, you must adopt additive now, or you must adopt additive in the near term?
There's still going to be, either way you go, there's still going to be room for the job shop. Even on that part that I showed, there's still some machine work that has to be done, whether it's position or whether it's diameter, to hold the tolerances and things. So job shops are not going away. In fact, in my early career of starting with 3D printing, I used to have the machine shop sneak in at night and turn my printer off because they were afraid that it was going to take work away from them. Well, what they finally realized was this was getting work for them because we were able to produce more parts. So I don't want the job shop to be scared that they have to get into this kind of design. They don't. They still will be around, but they need to be able to embrace it and know that it's coming down the line so they can be prepared and ready for it. Or that's one side, they're still going to have a job, or they embrace it early and become the pioneers of it and specialize in it so they get that early business and experience with it.
All right. So that your answer was coming from the generative design aspect. Now, what about additive in general? Does every shop need to adopt it now? Additive?
There was a time when we would go to shops and they'd say, "Oh, we don't need it. We don't need it." And now it's become so mainstream, they're realizing that they can't not have it. It's an expectation. Things that we didn't expect 10 years ago, 30 years ago, they're commonplace now. 30 years ago, 20 years ago, nobody had a printer in their house or their own computer even. Now everybody has an inkjet printer at least in their house. Nobody, I think, has a dot matrix anymore. I hope not. And even you think about automotive manufacturing, you realize there was a time when we paid extra to have electric locks on our doors. Now you couldn't buy a car without automatic door locks on it. It'd have to be a special order. So you're going to see the job shops migrate in that direction where they're expected to have that 3D printing capability to at least give the customer an idea of what the part's going to look like.
All right. So let's get a time frame on that. So if a job shop isn't serious about additive right now, do they need to become serious about it this moment in time, or do we have years, several years before the pressure builds?
They're almost overdue right now. If they don't have it right now, they're almost overdue. Really, in my opinion, I see that all the time out in the industry. I have people that would call and say, "Hey, we don't have 3D printing. We know it's the coming thing. Help us decide what we got to do to get into 3D printing," because they know it's the coming thing. So if you're not looking at it now, you could almost be left behind.
All right. One last closing question, then a big open-ended question for you. But the last question I have is, what's your position on additive manufacturing and being a disruptive or displacement technology, meaning that machining and boring and turning and bending go away? Which
it's never going to replace all those things. It can only enhance the machine shop. It's, in the early days, we always thought, it's going to replace all this stuff. It will never replace it. It's only going to enhance it. You're still going to need machine shops out there. There was a time when machine shops made buggy whips. Well, they adapted. They don't make it anymore. They make something else. And as long as we're still growing out there in our industries, technology is moving at such a fast pace, you're still going to have to bend sheet metal.
Fair enough. Now, you've got a lot of experience. So were you in a shop that was actually making buggy whips, Mark?
No, but I remember my grandfather teaching me how.
Yeah, all right. Well, I'm going to wrap this up with one big open-ended question, as I just promised. Mark, any closing thoughts, comments, or anything that you really believe needs to be shared with the audience that we didn't touch on?
One thing we didn't touch on that I'd like to share is when you buy a 3D printer, especially if you buy a professional one that you're going to pay high dollar for, take a part that your company makes, whether it be widgets, whether it be knobs, whatever. Take a part that your company makes and build it on that machine, and take that part and set it. And I do this on a mill and a lathe. When I spend a lot of money for a mill and lathe, I'll take that part and I will set it aside with all the data, the program on it that I used, the tools I used on it. Maybe I'll have a PDF form, that all the parameters I used, and set that aside and put it in a box and label it, such and such a date, such a part for such a machine. And then 4 years later, come back and run that same part. Because if you're paying for maintenance on machines and there's any wear on that machine and you don't get the same part out of it, come fix it. Come work on it. People tend to think of these machines, they are. They're just like your automobile. You drive them, you don't have the same pep anymore. But if you're paying for the maintenance, you need to make sure that you've got the same quality that you started with. It's the last thing I'd add for advice.
I appreciate it. Well, let me close this out by thanking you, Mark, for taking the time to spend with us and sharing your insights and your observations. I also want to thank our sponsors for their support. That's Trumpf and Thermoid. Without them, this wouldn't have been possible. And do me a favor. If you have needs for metal additive manufacturing or any work in cutting, welding, bending, forming, and marking, give Trumpf some thought. To find more details on their offerings, visit www.trumpf.com, or you can send an email directly to oeminfo@us.trumpf.com. And for your large-scale additive manufacturing needs or 3- and 5-axis CNC routers, please give some thought to Thermoid, with information available at www.thermoid.com. And I can't conclude without thanking you for joining us in this episode. We really hope that the information that we brought forth, that Mark shared with you, offers some insights that benefit you in your additive manufacturing endeavors. And by the way, if you know someone, or if you are that someone that has insights and observations that would be beneficial for other job shops to hear, we want to hear from you. Drop us a line at andyf@fmanet.org. And with that, ladies and gentlemen, thanks once again. We wish you all the best in your AM journeys, and have a wonderful day.